Okay, so logarithms, so we're going to learn that today, are just the reverse of an exponential. Okay, so we're just going to do something super quick here. You don't have to write it down if you don't want. Okay, so if I do exponential, something like this. This is exponential, okay? Do you remember what it did? So is this going to have a normal y-intercept or somewhere else? Normal. So just at 1, and then it's going to increase, right? Okay. So this is a basic exponential based on a base of 10. So that's why I have the coordinate 1, 10, because 10 to the 1 is 10. Okay, the next coordinate would be, does anybody know the next coordinate way up here?
15.
It'd be 2, what happens if x was 2?
20.
What's 10 squared?
Oh, 100.
100. What's the next one way up there? 3, 1000. Okay, you see where I'm going? Okay. Versus y equals log x. What is it going to do? It's just going to take your coordinates and reverse them. So you're going to have the coordinate 1, 0, and you're going to have a coordinate 10, 1. Okay, we do a lot of this in pre-calc, graphing. Okay, for you guys, obviously your calculator is going to do the graphing. Okay, if you just see the word log, it's using the base 10. Okay, so this is how you write it with other bases. Okay, but you aren't going to see a base, but it's using a base of 10. Okay, so it's really going to be looking like that, and it's just like this secret base number of 10. Okay, so here we go. Y equals, I need you to write log x. Do you know where your log button is? So it's over here on the side, couple up from your on button, just log x. Okay, I'm going to do a zoom 6 on it, just to I have no idea what my graph is looking like right now, so zoom 6. And it looks like this. So if I trace the mouse to see what's going on and stuff, it always starts at 0. And if you look here, there's no y value at all. So when x is 0, there was no y value. So what does that tell me about this? Do you remember that funky word?
Asymptote.
There's actually an asymptote there. So what is your graph doing? It's actually never hitting that axis at all. And this is showing you it's never touching. There's no value there, okay? So that's that asymptote. Can you hit trace 1? Did it work out? Is there a coordinate there at 1, 0? The reverse coordinate of what we had going on over here, right? Then what do you think is going to happen way over here? Let's try to go to trace 10. Is that a match of what we were thinking the reverse coordinate would be? Okay. Now, can you go back to your y equals screen? And now I want to put a 2 in front of that. Do you guys know how to insert a 2 without overlapping? You have this insert button. You can go second, insert, and then it allows you to type into that spot without overlapping. Okay, if you want to retype the whole thing, you can do that too. Good? Okay, I'm getting the same concept here. If you can see yours, when I hit trace, there's nothing going on in the Y, which is telling me asymptote. It's not touching that axis at all. Why don't you try the trace 1? Okay, so that didn't move. So what is changing here? Why don't you try trace 10? Mine is different now. That's where something changed. Okay, can we make any predictions here without our calculator?
No.
Do you think it's going to make the same shape?
Yes.
Yes, so same shape. Do you think it's still going to have an asymptote?
Yes.
Yes. What do you think about the x-intercept?
1, 0.
Same. So what is the 5 going to actually change? This coordinate is going to be going up faster at a faster rate because you're timesing by 5. So it's 10 comma 5.
Then the next one would be like 20, 25.
So the original next one on this would have been 100 comma 2. So I would have 100 comma 10 because you're timesing by 5. So the 2 times 5 is 10. So the next coordinate would be, does that make sense? 100 comma 10. On this one, 100 comma 2 would be 100 comma 4 because double. Yep.
Wait. I had times by 5.
On this one it did. So, because our originals was like, if 10 to the 1 is 10, 10 squared is 100, right?
Yeah.
So then times this by 5. That's why I got 100 comma 10. That's it.
Okay.
Yeah, that's very pre-calcy. You don't have to really be able to do that. Okay, let's see what happens on this one because now it's a negative value. So what's going to change? Are you getting a log but it flipped? Does that make sense? It kind of flipped itself over. Okay, what is the x-axis or the x-intercept?
There is
This one, the x-intercept, there is one there.
Oh.
What is it at? Is it still at 1? What is the y-intercept?
There is not one.
There is not one. What is the domain? So where do our x values start at?
1, 0,
0, but not
to infinity.
on. You can't hit 0, right? To infinity to the right. What is our range? So what's the lowest?
0.
No.
Negative 5? No.
What am I doing here on my graph? I'm going down, 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 down.
Negative infinity?
Negative infinity. to how high? Positive infinity. End behavior, so we're in quadrant 1, and then we move to quadrant 4 as we're decreasing as we're moving. We're going down.
Do we have to start decreasing?
On these ones, yeah, because like the exponential, it was always from quadrant 2 to 1, but sometimes we were going up and sometimes we were going down, but it's still a quadrant. Okay, we're going to enter this one now. So what this is, I'm not going to go into too much detail because you don't have to know. My pre-calcers have to do everything by hand, so they need to know great details. But this is called the ln, which means the natural log. So now instead of using a base of 10, it's using a base of that e number. Who remembers e as a value-ish? Do you remember its decimal value? It's not 3.14.
That's pi.
That's pi. 2 point, close. 2.7-ish, yeah. Okay, so type 12 ln of x. So it's not using a base of 10. It's actually using a base of e, which is this number, 2.7-ish. I'm going to make my window a little bigger here. I don't know what I want to see. So it's that ln shape, or it's that log shape. Okay, can you get me an x value? X-intercept value?
0. 1.
1.
To 0.
The x value is 1. Where's the y-intercept?
9.
None. What's the domain?
0.
Same.
Will it always be the same?
Uh-huh.
Actually? Except on a word problem.
Yeah, word problems. And you gotta figure out the variables. Same, right? The range, still down and up. And we're gonna change this though. We're gonna say we're going from quadrant 4 to 1, and we're increasing at a rate. So logs are used mostly when you're increasing, but what's happening is that you increase slowly. Like it's not going exponential. Do you know what exponential does? It increases like fast, right? But logs increase very, very, very slowly. Okay. I'm going to just skip the last one. I think that, do you have a blank? Oh, wait. This is perfect. This chart is what I wanted you to make, and it's already here. Okay, so we're going to talk about the comparables. Okay, exponential. We looked like, this was our first graph. We either looked like this or this. Those are our two options when we did exponential. Okay, so we knew this graph was increasing if this base number was bigger than 1, right? We increase, we grow, and this was called the decreasing graph if this was less than 1. Okay, logs are going to look like this or like this. Okay, and then
Why not log?
your calculator only ever does natural log, so. Okay, so the difference was this number. And then that number was either positive, looked like that, or negative, and it flipped. Right here?
Yeah.
Y equals A times ln of x. So we talked about those two, log x. So what's the difference? This uses a base of 10 and this is using a base of e.
And how do we know?
The questions will all like tell you.
Oh.
Okay, and mostly you're going to probably actually work with the natural log. Okay, you don't have to know much detail because your calculator is doing all these things for you. Okay, I would love to dive into this, but it'd just be like way too much info that you don't need.
Yeah.
Unless you want to take pre-calc.
No.
Okay, your calculator is going to be doing all that kind of stuff for you, that thinking part. Okay, ready? What is the domain of our exponential graph?
0 to infinity.
Nope. Domain.
0 to negative.
What's the left on this? What's the right on it?
Negative infinity to positive.
Negative infinity to positive infinity.
Wait, but the last page it wasn't that.
Nope, because that was a log. Now answer your question. What's the domain on this?
0 to negative infinity.
0 to positive infinity. Because you're going from 0 to the right. No square on that, because you don't touch it. Okay. Day 1 graph. What's the range on this?
1 to infinity.
0 to infinity. Because you get close to that line, but you don't touch it. What's the range on this? Down to up is? Do you notice anything?
Yeah, they're the opposite of each other.
They're the opposite. So the domain of this is the range of this. They're opposite of each other. Okay? And I kind of had told you this. It's not a really big important detail, but your coordinates are switching. So if your coordinates are switching, x and y are switching, what do you think domain and range are going to do? Also switch. Okay, what was the normal intercept here, the y-intercept?
1.
0, 1, unless there was a multiplier, by the way. It was 0, 1, unless there's a multiplier and it changes, right? What is the y-intercept on the log one we did today? Where's the y-intercept?
0. 0. None.
None. What is the, back to the exponential, what was the x-intercept on this graph?
None.
There's none.
Oh my gosh.
And what is the x-intercept on this one?
0 to 1.
1. Okay, so what happened with x and y intercepts? They switched ideas. Okay, you also know this. On the exponential, you were getting a asymptote like that, but what was happening on the logs?
Reverse asymptote.
You were getting an asymptote Okay, so everything's kind of switching roles here, all your criteria.